Earth Systems 3209, Unit 3 Earth's Materials. Unit 3 references can be seen in the textbook in Chapters 2, 3, 6, 7, and also in Appendix A and B of the Curriculum Guide. Unit 3, Topic 1.4 will discuss mineral properties. The focus here will be on identifying and describing other mineral properties that can be used to identify minerals. These mineral properties are less common and are not as reliable as the ones discussed in the last recording, such as streak, cleavage, hardness, and specific gravity. All mineral properties. Each and every mineral property has certain properties. The properties of each mineral depends upon the following: the type of elements that are present in the mineral, the arrangement of the atoms, and the strength of the bonding within the minerals. You can see references in the text on page 40 to 44 discussing these mineral properties. The following are a list of physical properties that each mineral may display: specific gravity, hardness, streak, and cleavage. These four properties are very reliable and are commonly used when trying to identify an unknown mineral. Other properties that can be used under certain circumstances include fracture, luster, crystal form, color, taste, feel, magnetism, acid test, and fluorescence. Mineral properties 5 through 13 can be used to identify certain minerals and to narrow down choices between minerals that may look similar. If we look at fracture, fracture is where a mineral that do not have any cleavage planes is said to break along a fracture. Examples is glass or the mineral quartz, which is said to have a conchoidal fracture. We can also have other types of fractures, as seen here in this mineral. Another example of a mineral that exhibits fracturous cleavage is asbestos. This mineral displays a fibrous fracture. If you notice in the diagram, you'll see all of the particles of asbestos basically peeling off in little hair-like fibers. So asbestos has a fibrous fracture. Another mineral property that can be used when identifying minerals is luster. Luster is the appearance of the mineral in reflected light. Most minerals can be described as having a metallic luster or a non-metallic luster. If it has a metallic luster, the surface reflects light as if it was a metal, whereas non-metallic lusters do not look like metals, but they can have a variety of different lusters, such as glassy, greasy, earthy or dull, and pearly. Most minerals can be described as, number one, having a metallic luster. In these two diagrams, we see a diagram of pyrite in the first picture. If we look at the surface of that mineral, it appears as if it is a golden color, and gold is a metal, therefore would have a metallic luster. The second picture shows a shiny silvery appearance. This shiny silvery appearance, again, looks like it's a metal, therefore galena would have a metallic luster. Other minerals can be described as having a non-metallic luster. For example, a glassy luster. So if we look at the mineral samples here in this picture, we see that all of the samples appear as if they were little pieces of glass. And the surface, the way it reflects light, would be as if it had a glassy appearance to it. So these samples would have a glassy luster. Another non-metallic luster is called a greasy luster. And greasy luster is demonstrated by graphite. Graphite appears if the surface looks a gray, greasy color, and it is actually fairly slippery when picked up and held in your hand. So graphite would have and demonstrate a greasy luster. Third non-metallic luster is one that's said to be earthy or dull. They don't have any shiny surfaces or any glassy surfaces. Instead, they're more dulled type in appearance, or they basically look like soil and earth. So they would be considered to be earthy or dull luster. And in this case, we see bauxite, mineral bauxite, which would display this luster. A fourth non-metallic luster is called pearly luster. Pearly luster is demonstrated by talc. If you saw a mineral sample of talc, the actual surface would appear to be a pearly color. So therefore, talc demonstrates a pearly luster. Another crystal property, or another mineral property, that could be used to identify mineral samples would be crystal shape or crystal form. Crystal form is the mineral describes its visibility external shape. It can apply to an individual crystal or an assembly of crystals. And in this case, we see a cluster of crystals put together. And on the surface, which they look like flat surfaces, much the same as cleavage planes. But in this case, they are called crystal faces. And these crystal faces are common when you look at a mineral in crystal form. So crystal form would be another way we can determine one mineral from another. Another mineral property that could be used is color. Color is the actual color of the mineral that you see. This property, on the other hand, is less distinctive. It is not as reliable as others. And there's two main reasons why color is not a very reliable property. One reason is different minerals can have the same color. In the diagram below, we look at the two mineral samples, one being halite and the other being calcite. Even though they have different cleavage planes that we can see from here, halite has a cleavage of 3 planes at 90 degrees, whereas calcite also has a cleavage of 3 planes, but they're not at 90 degrees. It has a rhombohedral cleavage. Both tend to look as if they are both glassy, so they have the same luster. Therefore, they appear to be very similar. So color, in this case, where they look to be the same color, would not be a very distinctive property, whereas cleavage would be a very distinctive property amongst some others. The second reason why color is not a good property to identify minerals is some minerals may have impurities within them, which cause the single mineral to have many different colors. One such mineral would be quartz. Quartz can take on as up to several different colors. In this case, we see crystal quartz, which is clear. We see amethyst quartz, which is a purple color. We see citron quartz, which is a yellowish brownish color. And we see smoky quartz, which is gray to black in color. But all 4 minerals, even though they appear different colors, they are all the same mineral. So this is why color is not a good property to identify minerals. When we look at some other mineral properties that can be helpful in identifying minerals, one could be taste. Taste is what the actual mineral tastes like. For example, halite. Halite is rock salt, and it has a salty taste. Even though that taste is not a recommended property, it can be used in some cases. For example, when I'm trying to identify halite, which again, in the last slide, we saw that halite looked a lot like calcite. So if you, under very careful supervision, had tasted the halite, it would have a salty taste. So we could use taste to identify halite. Another property would be feel. This is what the actual mineral feels like. An example of a mineral that can be used to find the field would be graphite. Graphite, when held in your hand, would feel very greasy. So this mineral property, feel, can be used to identify graphite. Another mineral property that can be used is magnetism. If a mineral is magnetic, it can have things stick to it, much like paper clips, as we see in the diagram to the right. So magnetism could be a prime mineral property that some minerals could possess, such as lodestone or magnetite. Another mineral test that can be used, and is often used in the field when a geologist is trying to test for carbonates, is the acid test. So during an acid test, you drop acid on the sample to see if the mineral reacts, or if we see it fizzing. Used to test carbonate minerals such as calcite, which is the primary mineral in limestone. The diagram to the right shows an acid bottle dropping a bit of acid onto the mineral calcite, and as it does, it reacts with the calcite, producing a fizzing action, which reacts with the mineral itself, releasing carbon dioxide bubbles. A 13th property, and final property here, is one of fluorescence. Fluorescence is the emission of light by a substance that has absorbed light. Fluorescent minerals emit visible light when exposed to ultraviolet light. So if you take some of the minerals which contain minerals that react to ultraviolet light, when you expose them to this light, they will glow certain colors, as seen in the diagram below. And some minerals can be identified using fluorescence. Let's look at some examples from past public exams. Example 1. First question reads, which mineral property is evident in the diagram below? So if we look at the diagram here to the right, we see a chisel breaking a mineral sample. But along the break, we don't see any smooth, flat, parallel surfaces. So therefore, it do not break with cleavage, and instead it breaks with fracture. So the answer to the first question will be B, fracture. Second question reads, which mineral property refers to the quality of light reflected from the surface? So if we look at the property which deals with reflected light from a mineral surface, the answer would be C, luster. Luster is the way a mineral reflects light. Example number 2. First question reads, minerals are commonly identified using physical criteria. For which of the following does the description match the test? Our choices are as follows. A, fracture, is the tendency of a mineral to break in an irregular manner. B, reads cleavage, is the appearance of a mineral in reflected light. But we've previously discussed that the appearance of a mineral in reflected light will be luster. Choice C reads luster is the color of the powdered form of a mineral. And previously we've discussed that the powdered form of a mineral when scraped on a non-glazed porcelain tile would be its streak, so C would not be the correct answer. And D, streak, is the resistance of a mineral to scratching. Previously we discussed that the resistance of a mineral to scratching is known as its hardness, so D would not be a viable answer. So the answer to this question will be A. Fracture is the tendency of a mineral to break in an irregular manner. Next question reads, which of the following minerals can be identified by its physical property of taste? So taste is a very distinct property and can only be applied to a very limited number of minerals. Our choices are apatite, basalt, which is not a mineral, it's a volcanic rock, halite, and graphite. And the answer to this question is C. Halite is rock salt, and if you taste rock salt, it would have a salty taste. So halite can be identified by using the physical property of taste. Your turn. Take time and complete the following questions. You can stop your recording now to prepare your answer, and the solution will follow on the following slide. Question. Question reads, explain why color is not reliable when identifying minerals. And when we look at the solution to this question, color is not reliable to identify minerals for two reasons. Number one, different minerals can be the same color. For example, halite and calcite, if you were to look at both in hand sample, they would look pretty well identical in color. But they have other distinguishing characteristics, such as cleavage and hardness. And also, calcite would react to an acid test, whereas halite could be tested by taste. So color would not be a good property to distinguish between halite and calcite, because both would appear to be the same color, unless they had impurities in them. And a second reason why color is not a good property to identify a mineral is a given mineral can have more than one color. So if you look at a sample of quartz, and quartz commonly made out of silica, commonly has impurities in it, quartz takes on several different colors, from amethyst quartz, which is a purple color, rose quartz, which is a pink color, crystal quartz, which is clear, smoky quartz, which is black, and the list goes on. So in summary, an overview of the points covered. The properties of each mineral depends upon the following. It'll depend upon the type of elements present in the mineral. It'll also depend on the arrangement of the atoms and the strength of bonding between the atoms. When we look at some less reliable mineral properties, these properties can be used to identify certain minerals, but they're not consistent through all minerals. These properties are fracture, luster, crystal shape, color, taste, feel, magnetism, acid test, and fluorescence.